Hello viewers, welcome back to another section of my tutorial. In this video, we're going to solve the properties of matter problem, and this is under Archimedes principle, that is buoyancy. Let's go into the question. If this is your first time visiting this channel, kindly subscribe and also you like the video. Gold, whose mass is 193 grams, is in kerosene, having an upward force of 8,000 dynes. If the acceleration due to gravity is 10 meters per second squared and density of kerosene is 0.8 grams per centimeter cube, then determine the density of gold. Take one dyne as 10 to the power negative 5 newtons. So I always say when you are tackling any physics problem, it's very advisable to draw a diagram for this. So you're going to have a container, and in this container we have kerosene in it. And there is a mass of gold immersed in it. There is a mass of gold immersed in this. So this mass of gold, as it was immersed, was opposed by an upward force of 8,000 dynes. Was opposed by 8,000 dynes. So that is a buoyant force. Buoyant force. So they are asking us to find the density of this gold. First of all, let's remember flotation, not flotation, but let's remember the Archimedes principle, saying that if a body is partially or wholly immersed in a fluid, it encounters a displacement which is equal to what? The weight of fluid. It displaces a fluid. If a body is being immersed, it's going to displace a fluid which is equal to its weight. So you will displace your own weight in every fluid you are immersed in. So remember that there is some kind of forces forces between the molecules in this fluid. So as this is being immersed, it is quite opposed by those forces. And generally we say that the weight of fluid displaced is the same as the buoyant force. The weight of fluid displaced is the same as the buoyant force. So FB is the same as the weight of fluids displaced. That is the weight in air minus the weight in what? Water. So if you weigh this gold in air and you weigh it in this water, the difference is equal to the buoyant force. The buoyant force. That is, you putting this on a spring balance in the water, you realize that this buoyant force is going to push it up to reduce its weight slightly. So that is the buoyant force. And remember, the buoyant force FB is equal to the density of the fluid multiplying the volume of liquid displaced times gravity. With these basics, I think we are good to go to solve our problem. So the density of the fluid is given. The volume of liquid displaced we don't have, but we have gravity. So meaning, to find the density of gold, what do I need? So you just have to solve some questions. Density of gold, what do I need? Density of gold. You realize that you need the mass over what? Over the volume. I already have the mass from the question, which is 193 grams. The volume, I don't know. So meaning I need a volume. And remember that everybody displaces its own volume in the fluid. So the volume is going to displace here is actually equal to the volume of the whole figure. That is the application of Archimedes principle here. So from the Buoyant's formula, I'm going to make my volume of liquid displace the subject. I'm going to have FB all over density of this fluid times what? Gravity. Now, what is my buoyant force? It was given as 8,000. Then don't forget that it said 1 dyne is equal to 10 to the power negative 5. So I'll convert it to Newton here, like this, all over my density. The density was given as 0.8, but since I'm going into the Newton, I have to convert it to what? Into kilogram per meter cube. So 0.8 times 1,000 here, and times 10, which is the gravity. So I push this forward. I'm going to get 0.08. That is 1, 2, 3, 4, 5. 1 2 3 4 5 0.08 all over this place is going to give me 800 then by 10. So my volume of liquid displaced is going to be 0.08 over 8,000, and that is giving me what? I'm getting 1 times 10 to the power negative 5 meter cube. So my Vd is equal to 1 times 10 to the power negative 5 meter cube. So right now I have my Vd, I can go straight to find my density. So my density now is going to give me density is equal to mass over volume as I wrote. I have my mass, so this volume is in meter cube. The volume is in meter cube. Then I have to convert my mass to also what? Kilogram. So 193, I'm going to get 0.193 kilogram. Then this is over 1 times 10 to the power negative 5 meter cube. So that I'm going to get my density to be equal to, I'm going to get my density to be equal to 1,09300 kilogram per meter cube. So 1,900, that is 19,300 kilogram per meter cube. So this is the density in kilogram per meter cube. And if you want to convert it to centimeter per meter, if you want to convert it to grams per centimeter cube, you just divide it by 1,000. So I'm going to get this is the same as 19.3 grams per centimeter cube. Thanks for watching the video. Don't forget to share, like, and subscribe.